Hi guys and welcome back to the channel. Not so long time ago I tried to convert a simple washing machine motor to work as a DC generator by replacing the rotor with two ferrite magnets which I got from microwave ovens. That experiment has shown that the motor can be turned into a simple generator. So in today's experiment I got another universal induction washing machine motor which I'll be using as a guinea pig to see if I can convert it this time to behave as a car alternator. So here I got the motor. Before trying it to convert it to behave as a car alternator, I have to test it to make sure that it's working. And how to do that? Well, it's quite simple. These universal washing machine motors, they are universal motors, so they will work on AC as well DC. So here I got the motor. Now it's time to test it to see if it's working. As the last thing I want, it will be a busted motor. So basically, in order to test it, we have to connect the two electromagnetic coils in series to the armature rotor. And how to do that? Well, you just have to follow the big connector and to have a look at the wiring so you know where to tap, because there are so many models out there, and to give you like a proper way of how to connect it, well, it's quite tricky because the different amount of motors out there. Now what I'm doing here, it is just placing the electromagnetic coil in series with the rotor coils, and if I will tap it here, the motor will start to spin. But let me flip it this way so you can see it a bit better, like so. Now you can see the motor is spinning in that direction, so clockwise, so it means it's working. Now let's switch to the other bobbin, to the other electromagnet, the bottom one, see if it's going in reverse. And as you can see, it's going in reverse, so the motor is working. Now let's move to the experiment, making it behave as a car alternator. So now I'll be limiting my power supply to 1 amp because I don't want a huge current going to the motor coils. So now I got the clamp set to volt reading, DC to be more precise, and also I was thinking where to tap it. Well, I think the best guess will be just to connect it to the brushes, and as I think the rotor will provide the most amount of current, so one side to one brush and the other to the other brush, like so. And now normally if I will try to spin, I am getting few millivolts, which is like nothing, barely nothing. It's not usable as it is. Let's try to power the coils, one of the coils. So from the test I know this side is one and then the other is this, like so. Now when I'm connecting the power supply to the electromagnetic coils, I see instantly that the PSU is going in the current limit. So I got a 0.3 volts at 1.17 amps running to the electromagnetic coils. In one way it's like just a basic short circuit of the electromagnetic coil. If I am spinning the motor, you can see I am generating around, let's say 1 volt. So you see by spinning the shaft of the motor, I'm generating 1.1, and if I spin it faster, I'm getting 1.1, 1.2 volts. So it definitely works. Now with the motor working as a generator, basically, at this point it's a car alternator, because the electromagnets are getting power and also we get power, which is less than what we got at the input. But now I want to show you something else. If I will be to power the motor coil from some simple batteries, like these two batteries I got here, these are two 1.5 volts batteries, and try to give power using that one. Let's remove this and keep the order. So this wire is going to here, this wire is going here, and now if I connect the battery, the small 2 cells battery, and try to spin it, I'm getting more. I'm getting around 2.5. So I'm getting more using two 1.5 volts batteries to excite the motor. Wonderful. Now let's take it to a step further. Actually, that will be to bring another motor into the mix and to connect this one to drive the other one. But first I need to have a look at some belts, as I think I need a belt for this experiment. So after I have a look through my stash of belts, I was able to find one, which I think is perfect. So here I got the motors. Both of them are identical, only this one has a slight bigger stator but I bet both of them have the same electromagnetic coils, as basically both of them are from the same brand. But anyway, let's move a bit further with this project. First, I will be taking this motor and connect this to power. Yeah, it works. Now this motor is ready. Let's take the other one and grab more wires in order to connect them. Basically, them two will go to the brushes, like so. Second brush is connected, as well the first one. We'll be moving the wire a bit further so they don't touch the belt when it will be spinning. And then I'll be taking the DVM, place it somewhere here so you can read it, like so. Move its wiring as well, and then like so. And after that I will be getting more wire to be able to connect the electromagnetic to power, like so. And here I have the two leads where the battery will go, and also the DVM. Let's set it to DC, like so. So here we got the DVM. Let's add the belt to the mix, like so. It doesn't have to be perfect, as this is just an experiment anyway. And now I will be trying to switch on the power supply, and as you can see the motor starts to spin slowly. And let's take the battery and add it to the mix. And now by connecting the battery, we can see that the motor is producing about 5.5 volts, which is not much, but if you stay and think, this is a relative low speed, so it's low RPM. Now the power supply is pulling about 3 amps at 10 volts, so 30 watts. So now let's take it a step further by increasing the power supply voltage to, let's say, 20 volts. So now that the motor are spinning at 20 volts, I'm pulling also nearly 3.5 amps. And now if I'll be connecting the battery again, what's the voltage? Well, it's nearly 18 volts. But also I have noticed something. When the battery is connected to the electromagnetic coil, the motor, it's slowing down a bit, and the current of the power supply is increasing by 10 milliamps. So let's turn it down so I will be able to speak properly without you hearing the loud windings noise of the motor. Now what I can do next is to take a simple halogen lamp. This one is rated at 35 watts, and try to add that one to the mix. And how to connect that without shorting the output of the motor, it's a bit tricky, but still manageable, I think. Like so. They look like they are touching, but they do not touch. Have to believe me on this one. Try to connect again the battery. The voltage is 0.3 volts, but that is because the power supply is back to 10 volts. Now let's go back to, let's say, this time 20 volts, and try to connect the load. I see a small glow. Let's increase more the power supply. So I was able to see a small glow. I don't know if you have managed to see that, but I will be simulating again because I see that the connection between the motors is a bit bad. So I have to find somehow to make them stay a bit together. And how are we gonna do that? Well, using some metal wire, just to make them stay for the test for the time being. And also I got a foam piece which I can jam between the two motors, so I can keep the belt stretched much better. Keep in mind, this is just an experiment. Now let's increase back the voltage of the power supply to about 20 volts. Now the spin is a bit more uniformly, so I'll be powering again the electromagnetic coils. So now with the motor properly secured, I will be increasing the power supply voltage to the maximum it can go. That will be around 30 volts. It may get a bit louder, but I am doing it for science. So now with the two motors spinning at relative high speed, I'll be trying to connect the coils to power, to the batteries. And you will see so. And you wouldn't believe it. The halogen lamp turned on. Yeah, it may output only 6 volts, but I think this is limited by the lamp and as well the lamp resistance. But I got a better idea. First will be to limit the power supply and to get another halogen lamp and to place that one in series, the other one. And now I got two in series, so the voltage can go a bit higher, like so. Both of them are connected and they are not touching. So now let's increase again the power supply to maximum 30 volts and connect the small battery. And as you can see, both of the lights turn on. Not as bright though, as the output voltage is just 8 volts. For two of them in series, I think it's not enough. But I think this may be because the motors are not properly mounted and the belt is not properly stretched. And if I try to stretch it, if I try to adjust them, the voltage will go a bit higher. But also, I want to check something else. I want to check what's the output voltage for these puny batteries without any load. So let's turn the motor, let's say to this time to 12.5 volts and see what's the voltage at the output. It's about 6 volts, 6.9 volts. So let's increase it again to 20. And the voltage is 14.6, same as a 3S LiPo battery. Now I'll be increasing it to the maximum of my power supply. It goes up to 23.2 volts. That's quite impressive from this puny battery. So let's try to go a bit further up. Here I got a standard 18650 cell. Its voltage is about 3.97, so it's roughly fully charged. And see how much that one will be able to provide at 12.3 volts. Well, it's providing about 11 point something, 10 volts, going down. So let's increase the power supply back to 20 volts and try again. This time we get, wow, 32 volts, 33 volts. And if I go to the maximum for my power supply, I'm getting about 44.4 volts. That's very impressive. I think now I will be able to power the two halogen lamps with ease. Just something I forget to mention. The motor will be pulling a huge amount from this battery when it's in circuit. Right? Both of them are connected and nothing shorts. So let's try again at 10 volts with the LiPo cell. Just died. So let's try at 20 volts and connect again the battery. It seems that it struggled to power both of them. But let's increase it to the maximum of the power supply, to the 30 volts. And try again. Both of them are light pretty well, I may say, as they're getting 5 volts each, as they are in series. That's quite good. But the power and supply is delivering. Now with the setup powered like this, I don't know how long this puny battery will last, but I see something else on which is quite interesting. The input of the motor quite high. It seems that it's feeding the motor, the one which spins, the other one, with 26 volts 0.5 and nearly 9 amps of current. That is wild. But still, it proves something. It's proof that this motor can be used as an alternator, as I think with some proper modification to them, they will be able to output more than current as it is. But to be honest, this is more than I got last time, so still is some improvement. But now I have to end this experiment, because I am planning to build a proper base for the two motors and to do more tests in order to come with another video on where this experiment will advance, or we have to go back to the drawing board. I hope I will see you all in the next video. Till then, have a nice day. Thank you very much for watching. See ya!